All right, boys and girls, it's time to look more at the derivative. We are entering section 4.3. And in this section, as you can see by the topics here on the top of the file, we got several things to talk about. But I think what we'll have to do is break this guy up into two videos, one dealing with the first derivative and the next video dealing with the second derivative, talking about concavity of a function, etc. So really, this is about, like as I say, takes your math graphing skills to a whole nother level. This is about how you can take the derivatives of a function and interpret what they mean, how they affect or tell you information about the graph of a curve. So let's get started with the first concept, which is when a function is increasing. Okay, a function is increasing, as you can see here in these bullet points, when the derivative is positive. Now think about that. What I'm saying is let's make sense out of this by looking at the slopes of a tangent line. Okay, so if you've got a point here on a curve and your tangent is positive, like this, pretend that's a straight line, that means the curve is doing something like this for that to happen. Because if you've got a negative tangent line, it looks like this, your curve has to, it can't go across it, it has to be descending. So if you've got a positive f prime, if you will, versus a negative f prime, make sure that you understand that what's happening is if it's a positive f prime, your function is actually increasing from left to right, versus if it's a negative, it's decreasing from left to right. Okay, that's the first thing. All right, so let's play around with the homework. It says find the intervals on which this function is increasing or decreasing. What that is it just becomes a study of the sign of f prime. Again, so you might have an interval that does this, and here's the thing. F prime could be positive, and then it can turn negative. That could happen. So what happens in the middle? I mean, if you've got a curve, let's say in green, that's increasing, and all of a sudden it's decreasing, what happens right there in the middle? What's going on? I bet what happened is you have a zero tangent, so m tan is equal to 0, or it could be undefined. The main thing is, the most important part that I didn't write in here is the change, later it is written down, in signs of f prime occur at critical numbers. And we talked about those, right? Critical numbers. So that's what's happening. When we study the sign of f, the first thing you do, number one, is find all critical numbers. Okay, so we'll take our function here. F of x is this thing. And I hope that makes sense. Oh, there should be an x there. All the way through this file, there should be a plus 12x. Okay, because I cut and paste that thing, so be sure, well, I'll fix that. So the work, I think I'll work in, let's see. Let's work in, I guess, this color right now. All right, what does it look like? Beautiful. Okay, so we're going to find f prime of x. Easy, right? 6x squared minus 18x plus 12. And I want to find what? Critical numbers. And how do I do it? Set it equal to 0. And look where it's undefined also. Don't forget. This is a polynomial. It's defined everywhere. But I notice if I set it equal to 0, maybe I get rid of that 6 somehow, factor it out or divide it away. I've got an x squared minus 3x plus 2. And we're finding, oh, nice and factory, isn't it? We get to factor, this is x minus, what, 1 and x minus 2. Cool. And we find the critical numbers are 1 and 2. Oh, I don't give myself enough room here. Okay. So the next step is step 2 is, let's do this guy, analyze the sign of f prime. And step 3 will be then declare your answer. So here's what you do. You take a number line you mark off where your critical numbers are, 1 and 2. This is going to, and we're going to check the sign of f prime. So the way you do that, if you might recall this from another class like algebra, is you try different numbers in between these critical numbers, like try x is 0, try x is 1.5 maybe, and over here try x is equal to 3, and you plug it into your derivative function. You plug it in right here. And I don't have a lot of space, so what I'll do is see if you can figure this thing out. What I'll do is when I plug this guy in, I've got a 6, he's positive. This guy's positive, of course. What I'm going to do is look at the sign. But if I plug in a 0 here, I have 0 minus 1, that's negative. 0 minus 2, another negative. A positive times a negative times a negative. The whole thing here is positive. And you know, at the end I like to answer it, so I just keep going with the analysis. So again, 6 is positive. Now I'm plugging in 1.5 here. 1.5 minus 1 is actually 0.5 is positive, and 1.5 minus 2 is negative. So a positive times a negative. This interval, if I can squeeze it in here, is actually negative. And I bet the next one's positive. Let's check. Positive. 3 minus 1, positive. 3 minus 2, positive. So this interval is a positive interval. What does that tell you? Well, here's the thing. Positive, remember, the function is increasing. Negative, it's decreasing. Positive again with the first derivative, increasing. So step 3, answer. So you would say something like f is increasing on, and you would provide that answer, and f is decreasing on, and let's put the answer in. Increasing is here, the positive intervals. So we'll say something like minus infinity to 1. I don't care about including 1 or not. And you could say union maybe, and then go 2 to infinity. Okay, and it's decreasing in the middle, 1 to 2. So it's decreasing on 1 to 2. And the problem is done. Okay, that's how that's done. All right, so it's interesting to see how you would figure out the sign. Now here's the thing, and I think in a couple of sections we'll be seeing that it must have a peak here at 1 and a valley here at 2. Isn't that interesting? From calculus, increasing, decreasing, increasing, this is a fundamental part of understanding the derivative. It tells us about the function where it's increasing and decreasing. You think that's not important? Hey, where's our profit increasing over this interval? Okay, I like it. Let's do one more. I think, what else do we do here today? The first derivative test. Yeah, that's actually in this section, the first derivative test. Another increasing, decreasing thing. So this time, f of x, same kind of problem, x over x squared plus 1. And I chose this one because, hey, not all functions are polynomials. So step number 1, let's find the critical numbers. So what we'll do, I like that other color better. Let's go to that color. Back to you. Okay, critical numbers. So we'll go f prime of x. This time, quotient rule. So x squared plus 1 quantity squared. Bring up the x squared plus 1. Derivative upstairs is 1 minus the top minus the derivative downstairs. It turns out to be 2x. So yeah, we have to mess around with this and make it user-friendly. So I might combine like terms. It looks like I've got 1. But then it's going to be x squared minus 2x squared, so minus 1x squared. And downstairs is this guy squared. What do we do next? Well, how much room do we have? Not a lot. We analyze the sign of this thing. Sign of f prime. Okay, so this is where I took out the number line. Okay, and oh, we didn't find the critical numbers. Back up, back up, back up. What am I doing? I'm getting too much in a hurry. The critical numbers, therefore, are where it's undefined and where it is equal to 0. And if we've done enough of these things, we take the numerator, 1 minus x squared, set it equal to 0. You know, that factors as a difference of squares is one way to handle it. 1 plus x, 1 minus x, and you're realizing x is plus or minus 1. Take the downstairs, which is x squared plus 1 quantity squared, and I look at that guy too. Why? Because it could be undefined. However, this is never undefined. There's no solution to this. You cannot get an x squared that makes a negative 1 to cancel with the positive 1, so there's no solution here. Okay, step 2, we'll analyze the sign. Sign of, in this case again, f prime. Now I take out the number line, okay? And I mark off my critical numbers, which are at -1 and +1. And then I plug in numbers. I plug in numbers that are on either side. So how about x? I wanted green. Give me green, will you? Thank you. So say x is -2, maybe x is 0, maybe x is 2. And we're plugging that into f prime. You know what I like better as a form of f prime is this. I like it factored 1 minus x, 1 plus x over this thing squared. You know why? Because it's easier for me to see the sign when I do that. So when I plug in -2 right here and here and here, -2 gives me 1 minus a -2 is plus, that's positive. 1 minus 2 is negative, and downstairs, did you notice it's squared? It's always positive. In fact, on all of these, the bottom is always positive because of this square. Okay, well, what we have in the first one is we have a negative result. So that means your curve is dropping, okay? But in the middle, 0, you got a, looks like we've got a positive, positive. So the whole thing is positive, and your function is increasing. Lastly, when you plug in x is 2, 1 minus, this is negative and positive, and the whole thing is negative, and your curve is dropping like a stone, like so. Hey, we know the intervals of increase and decrease, so 3, why don't we answer? F is increasing on, F is decreasing on, and you state the answer. So the answer in this case, increasing is in the middle this time, so it's really -1 to 1. -1 to 1. The other guy, though, is minus infinity to -1 union 1 to infinity, and this one is done. So that's intervals of increase and decrease. Okay? A lot of stuff there. We are so close to finishing this kind of problem. What I did is I looked at the homework and I saw he asks you a whole bunch of questions, and I break it down one piece at a time. So the first question he asks in the homework is, where's the function increasing, decreasing? We just did that. And this would be a nice place to stop the video, but I think I might move on to, or do I want to move on to this next page? It's the first derivative test. It kind of goes fast. Watch this. Okay? So the first derivative test is this. The first derivative test doesn't go fast. The slow part about the first derivative test is what we just did, finding the increase and decrease. Here's what the first derivative says. We can tell where the function has its high and low points simply by looking at the first derivative, the sign of the first derivative. So if the first derivative, this is what you want to know, if the first derivative changes from positive to negative, you've got a max. Meaning, if it goes, oh, I've got a positive first derivative, so I'm increasing. Let's say this is my number line, and this is the number a on the x-axis. But then after that, it's decreasing, okay? Then what we have is we have a max of f of a, if this is like f prime, right? Likewise, if you've got the number line and say this is b, and you notice, oh, I've got a negative, but then it turns positive. What turns positive? Let's say that this is g prime. Then you'd say, I've got a min of g of b. Do you understand? I'm just doing it abstractly like that. It makes sense, doesn't it? It makes sense that if you're going up and then back down, you must have gone over a hill. Or if you go down and back up again, you must have gone through a valley. What if it does this, though? Sometimes they do this. One is positive. Okay, here's your number line, and this is C maybe. So you're going up. and then after the critical number, it's still going up. Well, that's not a max or a min. That's what I call a wiggle point. And for that one, I think later I might have said, why don't you think about what about y is equal to x cubed? That's the guy that does this. He has a zero tangent for a moment, but he's increasing and then increasing again. That can happen. And likewise, it could also be, negative down again. And so there's no max or min here or here. But these are the cases you're looking for, especially when we're doing optimization problems. Now remember, on this guy here, starting to not like green, it's a little light. I knew you needed to know that. On this one, if you go back up, this is why I think I can do this page. The hard part is done. The hard part is this. Remember that sign right there? Okay, so what's going to happen is I'm going to borrow that. It's 1 and 2, isn't it? So what we had for this guy is we had the sign chart. Remember there's an X here. Had the sign chart for f prime. It was at 1 and at 2. And what did it do? Up, down, up, I think. Let's take a look. Up, down, up. Yep. So we had a positive first derivative, a negative first derivative, a positive first derivative. So this guy is increasing, then decreasing, then increasing. According to the first derivative test, then, you can automatically say f has a local max of, and then you would write f of 1 and then compute it. F also has a local min of, and it would be f of 2, and you would compute that as well. Okay? Computing that I did not do. If I plug in a 1, I've got 2 minus 9 is negative 7, and 12 is 5 minus 3. I think it's 2. And if I plug in 2, I've got that's 16. Oh boy, minus 36 is minus 20. And then, but plus 24 is 4. I think it's 1, something like that. Now you might be wondering what that looks like, and later we'll be graphing this thing. Here's 1 and here's 2. Apparently, if I have my numbers right, it's got a max at 2, it has a min at 1. If I draw this in another color, I don't know where it crosses. That's part of the homework in a later section, but this is a polynomial, and I'm thinking we're looking at what it's doing. It's got a local max, it's got a local min. Pretty cool. All right, so let's finish this off. Let's go back to this guy, and it was negative 1, 1, down, up, down. Okay. Got to be, okay, so this guy was, here's f prime, negative 1 and 1, and what we found was negative, positive, negative first derivative. So it's down, and then it's up, and then it's down. I don't know where it's crossing or anything. No one's saying that. We're just knowing it's increasing, decreasing, and having a max. So what we would say automatically here is we'd say, hey, you know what? F has a local min of, in this case, f of negative 1 equals blah. And f has a local max of f of 1 equals blah. And so figuring that out, it's negative 1 half, negative 1 over 2. And plugging in 1 is 1 half. Okay, and if you're ambitious, you go, well, at negative 1, it has a local min of negative a half. And at 1, it has a local max of positive a half. So you can imagine the curve, I don't know what's going on, something like that. It has a local min and a local max. And that's a longish one, but it does cover the first derivative and how it affects your graph. And it also allows us to be able to find local maxes and mins, which when we get to the optimization problems towards the end of the chapter, you set up your own function, you find the maximum, you solve real life problems. Okay, see you in the next video.